Hello everybody. Today I can prepare for my quarterly exam by practicing. There are 22 questions on the review sheet. That means there are 11 questions on your quarterly. Let's get to it. For number one, there are variables in the problem and variables in the answers. The most efficient way to do this is to store a value for x, type in the original problem, 2x cubed plus 3x squared minus 4x plus 5 over x plus 3. 2265 over 13. Now I'm going to type in each choice. I'm just going to skip right to the right answer. I believe it was choice 2. 2x squared minus 3x plus 5 minus 10 over x plus 3, 2265 over 13. If it matches up, it's the answer. If it doesn't, it doesn't. That's the most efficient way to get to your answer. However, if you want to do this mathematically, synthetic division, 2, 3, negative 4, 5, capital L with a long bottom. The opposite what I'm dividing by goes outside. First number comes down, multiply, add. Outside times bottom, negative 6, add. Multiply what's outside with what's on bottom, 9, add. Multiply, add. I decrease my original highest exponent by 1, so it's 2x to the second minus 3x to the first plus 5, and the remainder goes over the divisor. Number 3. The zeros hit the x-axis. The factors don't. The zeros hit the x-axis. So, if x plus a is a factor, then negative a is a 0. And if x minus b is a factor, then positive b is a 0. Since there's a squared, this is a double root. So I'm looking for a double root in the negative territory and a positive root in the positive territory. So there's my double root in my negative territory and my positive root in my positive territory. Those two are out. Now, since there's a negative in front, it opens down. It would have to be choice 3. If the negative weren't there, then it would be choice 1. So again, if there's a negative in front, it opens down. If there's a positive in front, it opens up. Number 5, I see variables in the problem, variables in the answers. I'm going to type in the original problem, x squared minus 5 squared minus 6, x squared minus 5 plus 5, 8460. I type in each choice. I believe the answer is choice 3. Let's find out. And of course, you're going to start with choice 1 and just go through the process. X squared minus 10. X squared minus 6. 8460. The other ones were all not 8460. That's it. And if you're watching this, there's a small typo on number 6. I'm sure I told you in class, but that choice should be x squared plus 7, not minus 7. Oh, and I guess we should do it the right way, right? I call this a substitution trinomial. There are 3 terms, but since there's a binomial there, I'm going to substitute y for the x squared minus 5. So it's y squared minus 6y plus 5. I factor the trinomial normally, y and y, minus negative and a positive is a negative, multiplies to 5, adds to 6, 5 and 1. Substitute back, x squared minus 5 minus 5. I'm replacing the y with x squared minus 5, and x squared minus 5 minus 1. I can combine like terms, so it becomes x squared minus 10, x squared minus 6, Can I factor further? No, they're almost dots, but they're not, because that's not a perfect square, and that's not a perfect square. That's it. Number 7, end behavior. Very easy if you know how to do it. If you don't know how to do it, then can't do it. As x approaches negative infinity, that means left. F of x approaches positive infinity, that means up. X is left and right. F of x or y is up and down. As x approaches positive infinity, that means as I go to the right, the graph is pointing down. Choice 1 and choice 3, there's no graph. I can type these into the calculator and look at them, but it's positive and it's even, so it's U-shaped pointing up. Choice 3 is odd and negative, so it is chair-shaped facing down. Left up, yes, yes, no, no. Right down, no, yes, 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 yes. Number 9, I want to know if these expressions are equal. I'm going to go to the calculator and I'm going to type each of them in. M plus p squared, well, let's store, I already have my 10 stored as x, so now I'm going to store 15 for y. X plus y squared. My left-hand side is 625. My right-hand side, x squared plus 2xy plus y squared. 625. 625 equals 625. Those are good. Choice 2, I've got x plus y cubed. I could just copy and paste the x plus y squared and change it to cubed. I could also, this is very similar to the previous one, I have to make all the 2's into 3's. X to the third plus 3xy plus y cubed. 4825, so 15625 and 4825 are not the same. And finally, choice 3, x squared plus y squared squared is 105,625. And we've got x squared minus y squared squared plus 2xy squared is 105,625. Yeah, it matches. We're good, we're good, we're good. 1 and 3 worked. That's your answer. I'm not even going to go over this algebraically. You'd have to do box method and more box method and combining, and I don't have time for that. Sorry. Number 11. I see variables in the problem. I see variables in the answers. Type it in. We're getting a lot of questions right with these strategies. Sorry, colleagues. 3x minus 2i squared is 896 minus 120i. I type in each choice. I believe the answer was choice 3. 9x squared minus 12xi minus 4. Again, the I button is second decimal point. Second decimal point. 896 minus 120i. It matches. If I'm doing this algebraically, squared means times itself. So it's 3k minus 2i times 3k minus 2i. And then from there, I'm sorry, I do it in my box. 3k minus 2i, 3k minus 2i, 9k squared, minus 6ki, minus 6ki, plus 4i squared. When I combine like terms, I get 9k squared minus 12ki plus 4i squared. I replace I squared with negative 1. I multiply that negative 1 through. Positive 4 times negative 1 is negative 4. And that's my answer. All right. Number 13. Is x plus 3 a factor? To determine if something is a factor, I need to find the remainder. To find the remainder, I do remainder theorem. So I'm substituting the opposite of what I'm dividing by in for x. So I'm substituting negative 3 in for x. I replace all the x's with negative 3's. And then I'm going to type it into the calculator and see what I get. I can do this with storing. I can do it without storing and just typing in parentheses. But I do need to show the work of that. I do need to see that work on your paper. I like to do it with storing. So I'm going to do negative 3 store as x. That way I don't have to worry about the parentheses or anything. But it doesn't really matter. 2x to the third plus 5x squared minus 31x minus 80 is 4. If the remainder is 0, it's a factor. If it's anything else, it's not. Since the remainder is 4, it's not a factor because the remainder is not 0. All right, number 15, it wants p of x to be 0, so I replace p of x with 0. Mr. X to the 4th, he wants to party. Before he can party, all of his friends are over. Good. Party time. Bubbles. Factoring. Is there a GCF? No. Trinomial? Yes. Since it's x to the 4th and x squared, I do x squared and x squared. First sign comes down, positive and negatives and negative, multiplies to 36, subtracts to 5, 9 and 4. You can factor one of them further, but either way, for the x squared plus 9, I have to do isolate square root. So I suggest you just do isolate square root for both of them. Minus 9 plus 4. I have x squared equals negative 9, x squared equals 4. Square root, square root, square root, square root. When you take the square root, it's plus or minus. The negative becomes an I, 3i, x equals plus or minus 2. There's no I for the 4 because there's no negative inside the radical. There are your answers. Number 17, solve the system algebraically. Well, I need to have a variable by itself in at least one equation. I have that, but if I can easily get y by itself in the bottom equation, which I can, that'll probably just make the algebra a little bit easier. Now, I need to substitute one equation into the other. If y is equal to negative 2x plus 11, I replace the y with negative 2x plus 11. Now it's Mr. X squared. He wants to party. All of his friends have to come over. Plus 2x minus 11. 0 equals 3x squared minus 2x minus 8. Party time. GCF. No. 3 terms. Trinomial. Tricky trinomial. Yes. X squared minus 2x minus 24. X minus 6, x plus 4. Pay the toll. Divide by 3. X minus 2, 3x plus 4 equals 0. Set each factor equal to 0. X minus 2 equals 0. 3x plus 4 equals 0. I solve each of them. X equals negative 4/3 plus 2 plus 2, x equals 2. Now that I have my x values, I need my y values. So I'm going to substitute each of them into one of the originals, whichever one's easier. So I got y equals negative 2x plus 11. Y equals negative 2x plus 11. Y equals negative 2 times 2 plus 11. Y equals negative 2 times 4 thirds plus 11. Y equals negative 2 times 2 plus 11, 7. Y equals negative 2 times 4 thirds. And you could store these values, but whatever. Negative 2 times 4 thirds plus 11, 25 over 3. Negative 2 times... Oh, I'm sorry, negative 4 thirds. Oops, that was a close one. Negative 4 thirds. That scrunchiness almost led to a mistake. Negative 4 thirds plus 11. 41 over 3. So the answers, when x is 2, y is 7. And when x is negative 4 thirds, y is 41 over 3. Number 19, Mr. X squared, he wants to party. All of his friends have to come over. Party time. Now this problem says to solve in simplest a plus bi form, which basically means it's not going to factor, but let's just follow our Mr. X squared story. Party time, bubbles. If I go to do bridge here, I would end up with a 22. Are there two numbers that multiply to 22 and add to 8? Nope. Bulb machine's broken. What is Mr. X squared going to do? All of his friends are there ready to party. He sings his song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you do start doing bridge, do not use the bridged values. Use the original values, but everything needs to be on one side. I substitute those values in. Negative b means change the sign of b. Negative 8 squared, negative 8 plus or minus 8 squared minus 4 times 2 times 11 all over 2 times 2. Make sure that the values you're subbing go in parentheses, especially this one. For whatever reason, students don't put it in parentheses a lot of the time. And if it's negative, it will be wrong. I type what's inside the radical into the calculator. Where's my calculator? 8 squared minus 4 times 2 times 11 is negative 24. A lot of students get messed up at this point. Now we take the radical negative 24, pop it off to the side. Negative becomes an I, reduce the radical. I'm not going to write out my list of perfect squares right now. 4 and 6. If you can't do this, then watch the video on reducing radicals. 2i rad 6. X equals negative 8 plus or minus 2i rad 6 over 4. I love quadratic formula. We draw our heart, we break it apart. Negative 8 over 4 is negative 2. 2 over 4 is 1/2. And the I rad 6 come down. And we're getting close. Number 21, it says to algebraically find the zeros. So I set it equal to 0, and I solve. Mr. X to the third, he wants to party. Before he can party, all of his friends have to come over. We're good. Party time. Factor. Is there a GCF? No. 4 terms is grouping. I find the GCF of the first group is x squared. If there's a minus in front of a group, I take a negative out. So the GCF of the second group is negative 4. X squared, x plus 1, minus 4, x plus 1. Negative 4 over negative 4 is 1. I combine my coefficients. Can I factor further? I see 2 terms. 2 terms is difference of 2 squares. Yes, they're subtraction. Yes, they're both perfect squares. So 2 sets of parentheses, plus and minus, square root of each, x and x, 2 and 2. The x plus 1 comes down. I set each factor equal to 0. Or we just know that if these are the factors, we know what the zeros are going to be. And I get x equals negative 2. I get x equals positive 2. And I get x equals negative 1. So that's the first part of the question. That's the first 2 points. The second 2 is to graph it. I mean, it's related, but it's not. To graph anything, it doesn't say sketch. To graph anything, we just go to the calculator, we type it into y equals, we plot our points. So if it said to sketch, then now that I had the zeros, I would just plot the zeros and I'd sketch it. But since it wants it to be graphed, I need the actual points, all the points to plot. So to do that, to graph anything, I just type it into the calculator. I go to my table, and I'm going to plot all the nice points. Actually, I feel like, nope, I don't feel like anything. So anything that fits. I got, those zeros are good, so negative 4, negative 36 isn't going to fit, but negative 3, negative 10 is. Negative 3, negative 10 is good. Negative 2, 0, negative 1, 0. 0, negative 4, 1, negative 6. 2, 0. So I plot them, negative 3, negative 10. I got negative 2, 0. I've got negative 1, 0. I've got 0, negative 4. I've got 1, negative 6. I've got 2, 0. If you don't know what this is going to look like, it is a little strange, these graphs, then just look at the graph, and we can kind of see what it's going to do. There is no domain, so I do need to put arrows. So I'm going to sketch it, connecting all those points. I'm going to draw arrows, and that's 4 points, and that's it. Is that it? Did I do it? I did it. That wasn't bad. It didn't take as long as I thought. There's 11 different types of questions. If you know how to do those 11 types of questions, you will get every question correct. If you don't know how to do those 11 types of questions right now, then it's on you to learn how to do them. You have this video, you have this answer key, you have a lesson, a video, an answer key on every single type of question that's on here. Just scour Schlansky.com to find them. And that's it. Practice, do well, goodbye.